Welcome back to our next inequalities video, everybody. And in this video, we're going to learn how to graph solutions to inequalities. So if you recall the last one or two videos, we discovered that inequalities, unlike equations, have a range of solutions. So if you look at the first inequality at the top left, 5 is greater than x is going to have a rather large range of solutions that we're going to display on a pretty small graph. So if you just guess a random solution, you can guess 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, and so on all the way to negative infinity. So how do we represent that on a graph? Well, if we were to assume x is equal to 5, what is that going to look like on our graph? That's going to be right here. So I don't have indents or axes values just to save a little bit of time and space. So if we assume this line represents x is equal to 5, now our solution is going to be any value to the left of that. So any single data point in this range will count as part of a solution. But how is it displayed on the graph? Well, it's usually shaded in. So whenever you have something like this, you're going to simply shade in this part of your graph, and that's going to be your solution. Now, what does this tell us? This tells us that any data point in the shaded area serves as a solution to the inequality. And if you look at this, that actually holds true. If you take any single data point that lies within here, and you can make your axes as large as you want. So this could be, negative 10,000 at the end or negative 80,000. But regardless of what values are on your axes, this shaded area is going to represent a solution for this inequality. Now you can plug in any value, take, some data point over here. That's going to have a negative x value, which is automatically less than 5. Take, 3 comma 5 has a x value of 3, which is still less than 5. So as long as it doesn't reach this solid line right here, it will count as a solution to your inequality. Moving on to the next one, well, x plus 1 is greater than 5. So in this case, we can set our y equal to x plus 1. Now, if we were to graph this equation, it would look something like that. So when is this value greater than 5? And specifically, when does this x combination get you a value that is greater than 5? So if you actually solve this inequality, you just get 4 is greater than x instead. Now, if you do the same thing as last time, let's say this right here represents 5, and this right here represents 4. So if you actually graph this solution, the line doesn't actually matter here. Your graph should look something like this. You're going to shade in the entire left-hand side of the graph that comes before 4, because that contains every single x value that is going to be less than 4. That becomes your solution to this inequality. Moving on to a third inequality, first we want to solve for whatever possible x values we have. Now 7 minus 5 gets you 2, so you get 2 is equal to 2x, and x is equal to 1. Now changing this into an inequality, this should be 2 is greater than 2x, therefore our x value has to be greater than 1. Taking the same kind of thought train as last video, or as last example over here in the top right, if this is 5 and this is 4, we can guess, about 1 right here. So what is the solution to this going to look like? Well, regardless of whatever your y value is in this case, all we need is a x that's greater than 1. So your graph should have the entire right-hand side shaded. Any value to the right of 1 should be shaded because that gives you a x value that is greater than 1. So that becomes your solution to the third example. Moving on to the last example, well, first let's solve. So we'll move our 5 over here, and we get 2x is greater than x plus 5. Moving our x to the left-hand side, we get, 2x minus x is x, so x is greater than 5. Now, this is going to be the exact opposite of our first solution. So, if we extend this, and if we call this 5 instead, 4 and 3 and so on, So if we just estimate these, actually let's make this 3 and 1. Now if we look at our solution to our inequality, as long as x is greater than 5, it's going to work. Now, what's different from the first example? Well, in the first example, 5 had to be greater than x. In this case, it's the exact opposite. So, once again, the right-hand side of this graph is going to be completely filled out. Because once again, this gives you any possible x value that can be greater than 5. So this is how you kind of graph basic inequalities. Now in the next video, what we're going to do is we're going to look at inequalities with either two variables or two equations and how we can solve those.